I think we are going. Check one, check two. All right. Hello, welcome. Thank you for wherever you're watching around the world. This is your Module 4 recap, Module 5 preview. Getting this in before our lecture on Module 5 tomorrow. Again, sorry for the delay here. I was out on a work trip all last week and I've spent the last 48 hours or so still getting caught up on everything. So yeah, let's start with Module 4. Again, that was our intro to SQL week. So thanks to everybody that was able to attend the live session on Monday. Even though I was not there, Karen did a great job covering in my stead. I posted the recording link in the announcements forum as well as in our Module 5 lounge. But as always, you can always find it by navigating to the Zoom content as well. I think it's on the student view near the top, kind of near the announcements section. Actually, I'll just show that real quick. Do, do, do. So, yeah, as always, you can find the recordings by going to announcements and resources, going to a live session, and you should be able to go to cloud recordings here and see all of them. So there's the recording from March 2nd, which was Monday. And again, I've also posted the direct recording link in a couple of forums for you all to find. So let's see, you should just be able to fire this up. There it goes. Cool. And we'll recap the lecture in a sec. And also just to note that if you do have any if you ever have any trouble finding the recordings or lectures, everything is also backed up onto my YouTube. I think I'll just close that out. So on my YouTube channel, you should be able to see all of my recaps and lectures and things as we go. Cool. So let's dive into week 4. In week 4, we dove into the core concepts behind relational databases and SQL, structured querying language, which are essential tools for working with data in real world workflows. Databases have been around for a long, long time. They've been around at least 50 years, starting with your on-prem Oracle, on-prem kind of SQL Server type environments, then moving into open source versions of those databases with Postgres and MySQL coming out in the 90s, and then finally evolving into NoSQL databases in the 2000s, and then cloud warehouses, and now cloud lakehouses and data meshes and everything in the 2010s and 2020s. So here we covered why our database is so important. Basically, they operate as a single source of truth to all of your data sets and allow kind of strict controls around what data is allowed to be there slash move forward in any ETL process. So that's kind of the role of a database management system. How do we provide that single source of truth of a large amount of information to many people in your organization? How can we also use that to power applications and again provide a consistent trust in the data that gets written to it using kind of relations and primary and foreign keys and normalization and entity relationship diagrams and stuff like that. So, how do we establish relationships between entities in a database, and why is that so important? So we covered all about that, like why your database is important, and then finally, what does SQL do on top of it? Note that there are many flavors of SQL. SQL Server is going to be written in something called T-SQL, and that's going to be slightly different than PostgreSQL, which is different than SnowSQL, which is different than BigQuery SQL, which is different than Databricks SQL, and even SQLite. SQLite has its own kind of crazy syntax in some areas. So a lot of different flavors of SQL that can be written across your databases, but they all fundamentally do the same thing. We talked about CRUD operations and we talked about analytical operations as well. So CRUD, remember that stands for create, read, update, delete. How do we create, read, update, modify, or delete or remove entities within a database, whether it's a row, a table, a schema, or even a database itself? We also walked through analytical queries using joins and group by, having, where, average, all that good stuff as well. Well, so that's kind of how week four started. What is a database? Why is it important? What is SQL? What are your basic core SQL commands? And then we ended week four by showing how we can use SQL as a data source, how pandas can, Python can read from a database, and then once you have that pandas data frame, do whatever you normally would, build models or make visualizations, etc. But how we can also then use databases as a data location as well. We can extract from APIs, transform, clean that data up, and then load that data out into or push it out into a database or a data warehouse. We also touched on big data systems. I've talked about data warehouses, data lakehouses a lot, kind of the new paradigm for data, just because of the sheer amount of it, is simply drop it into a cloud hosted location so we can scale almost infinitely. And then how do we also define and store data that may not have these strict entity relations or may not even have strict schemas to be able to put into a relational database? Now, so how can we just be more flexible in our idea of what a data ecosystem is, and then connect that back into modern data pipelines? Then we brought everything back together with a real world example. And I'm going to cover Lab 416 on this video. So hopefully we have enough time for that. Cool. Week four, just the last couple things I'll mention on it. It was a really long week as we did a lot. Again, if you were no one was expected to have any technical experience coming into this course. So if you had never seen SQL before, we really wanted to make sure to go heavy on what is a database and what is SQL. So that's about the first half of the week. And then the second half of the week is tying it back into our data science workloads. How do we connect to databases through Python and Pandas? How do we read data? How do we write data to and from databases? Then how do we use data from databases as a source for our modeling, predictive analytics, and visualization reporting? So if you do have SQL experience, I would definitely just skim through the first half of the week and focus on the Jupyter notebooks in the last few activities. Cool. So that's kind of the big idea for week four. And before we dive into Lab 416, let me preview week 15 or week five as well here. I was gonna say the last couple things I want to highlight for week four is not only do I have everything backed up on my YouTube, but I also back everything up on my GitHub. So for example, for module four, I prepared as if I was going to be doing the live session. So you'll actually see that I have like this README file that kind of gives a more in-depth overview of everything I wanted to cover. So again, like what is a database? Why is it important? The data definition versus data manipulation or modification, different SQL functions that we're going to be using, advanced queries, how to connect databases with Python, and then working through some of the nuances in the labs. So pretty good. Again, if you want some more overview of my notes, and then same thing with the big ideas file. You'll see this for every week, but I try and put in some like big ideas of things to take away, of what you should be getting out of the week. And I put this together myself with some help from AI, but yeah, this is stuff that I kind of review when I do the lecture. So definitely check my notes if you're not checking them already. All right, and that brings us to week five. So week five started this week. It started a few days ago, and our lecture for this is on Monday. So, what is week five? What's the purpose of week five? Week five is again a pretty large week. We're cramming a couple things that should probably be over multiple weeks into one. So, again, strap in. The first is going to be an in-depth view of pandas. So, we're going to be digging more into pandas data frames in terms of data manipulation, data cleaning, and just kind of the functions built into data frames that make them so useful for data science. So that's going to be where we're going to start, right? How do we start loading and inspecting data sets? How do we clean and prepare data sets? How do we perform exploratory data analysis on it? And again, that could be its own week, right? Just doing EDA and data cleaning with pandas. But luckily, we've already touched on data cleaning with pandas, with the API and web scraping weeks. And even kind of to an extent with the SQL week last week. So hopefully this should be more of just a supplementation as opposed to brand new ideas. However, in the second half of the week, we do get into brand new ideas. That is where we're going to be starting to build predictive models, specifically simple linear models. Ordinary, least squares, OLS. We're going to be building just your traditional line of best fit. What is a predictive model? Now, what is a linear model? And kind of what is best practice for building out these types of models in Databricks? We all know in Excel, Google Sheets, you can just kind of insert this line of best fit, call it a day. But what does that look like in Databricks? And not Databricks. Sorry, my brain's everywhere. What does that look like in Python and Jupyter Notebooks, right? So we're going to go from how do we make sure that our model training is robust using train test splits, reviewing more exotic linear model algorithms such as ridge and lasso regression. How do we evaluate models using MSE and R squared? How do we kind of reduce overfitting and get a more holistic view of our model on unseen data using cross validation and tuning hyperparameters with grid search? So this is all hardcore stuff that real machine learning workloads are going to utilize. How do we make sure our data is ready and we're not having any data leakage? How do we train multiple types of models? How do we kind of evaluate those models against each other? How do we optimize our hyperparameters? How do we kind of increase our trust in the model performance in the real world? All of that is the framework that we're building here, even if the context is still your simple linear or multiple regression models that we're going to be building. And when we get into machine learning week in a few weeks from now, we'll talk about kind of that linear models are still really good and should be used typically as a baseline for your more advanced machine learning models. If your XGBoost model doesn't outperform your linear regression, then what are you doing, right? Just use a linear regression. You don't always have to use exotic algorithms just because you want to, right? So yeah, by the end of the module, we're going to go from complete end to end of reading in data, doing some exploratory data analysis and data cleaning, and then building out some simple prediction pipelines using Python. So again, pretty fun week. Don't feel like you have to complete every lab all the way through. How many labs are there? I already forgot. Oh, how many labs are there? One, three, five, seven, nine. I think there's about 10 labs for week 5. So again, if you have some familiarity or comfortability with Python, or in Pandas, you can definitely jump through to the data wrangling in module 5.3. EDA in 5.5 is probably important. And then the predictive modeling stuff starts in 5.6 and 5.8. And then finally, we put it all together in 5.10, which is our little keynotes activity for the week, where again, you have no solutions and you're no hand holding, and it's kind of thrown into it on a real world data set. This is pretty good. It's a real world data set predicting housing sales in Seattle. So that should be kind of fun. And then if you get stuck in any of these, I've already run and backed them all up. So you can check my GitHub, you can run in Google Colab, kind of whatever you need to do. But definitely use this as a resource. Don't use it as a crutch. Definitely try this activity on your own. And this is also what we're going to be covering in lecture on Monday as well. Cool. There's some weird instructions in the notebook, things like take screenshots and upload the notebook. You don't have to do any of that. Um, but there will be questions from this activity on the quiz. So, same old, same old. Notice that you're not going to be submitting any notebooks or anything until our capstone in weeks 9 and 10. Cool. So, week 4, databases, week 5, pandas, EDA, and basic modeling frameworks. Cool. All right. I'm gonna take what extra time I have left to actually just show 4.16, just so you get a little bit of my live lecture here, even though it's on recording. So let me pull this up. 416 was the, oh my goodness, student. I don't want to be viewed as a student. Let me get this working again. Yeah, hold on. Let me return to my normal role. There we are. Sweet. In week five as well, there's some like weird typos where the code just doesn't always work, or some of the solutions don't always work. So if you see any issues, anything in the labs, I definitely also ran into them and I fixed them in my own notebooks. Like there was a couple where like the variable names are wrong and stuff like that. So don't worry, Karen's gonna help us log and report those back up. But again, if you ever run into any code issues, compare with my version and that should be able to resolve most of your issues. Sweet. All right, what we're doing? 416. Boop, boop, boop. Here we go. Hopefully, everyone's had a great week learning everything about SQL and predictive models. While this is loading, that's actually a good point. Um, I'm gonna drop these into kind of my recap for this as well. But if you go to Kaggle Learn, there's a whole bunch of these that start lining up with what we're doing here. So obviously the pandas activity is going to be really close to what we're doing. But if we actually start looking at the intro to machine learning, they'll actually start talking about some of the stuff that we're doing here about like EDA, what is a model, how do you validate your performance of the model. So both the intro to pandas and intro to machine learning are pretty good for this week. Um, yeah, I think just those two. And then if you haven't done the data cleaning, I forgot this one's actually pretty good as well. Yeah, you got the data cleaning one, which is also what we're doing this week. So maybe that's how I do it. I'd probably do intro to pandas and intro to data cleaning for week five. Because yeah, we do all of this. Cool. All right, so here is our activity notebook here. It looks like we're connected to our kernel and hopefully this just works. So I've already completed this as well, so hopefully we can just run through it. Uh, view, edit, clear output of all cells. Let's do it. All right. So we have three data sets here, real data sets coming from socioeconomic demographic indicators of Chicago and Chicago public schools and Chicago crime data. So first thing we need to do is grab all of these data sources. We've already backed them all up for you, so we're just reading them from cloud storage. But they did come from open like APIs through the city of Chicago. Yeah, most cities actually do have like open APIs. So even though I live in Dallas, we got like open API Dallas. I think that'll nope. Dallas Open Data Platform. Maybe that's what I'm thinking about. Yeah, there you go. This is like City of Dallas, like open data and everything. So if you want to like grab some of this data. So a lot of cities do this. New York has a really good one. Yeah, NYC open data. So this one's pretty fun. We may actually build a couple of like applications off of kind of these data sets a little bit later in the boot camp, actually. All right, so this works. We've installed our SQL stuff, and let's go ahead and first we're going to initialize our database, final DB. We're going to load the SQL extension, which will allow us to write SQL commands uh, in our notebook here. Let's read in the CSV into a data frame. We're going to print out the number of rows and columns, and then we're going to create a new table called census data off of that data frame. If it exists, we're going to replace the table. We're not going to write the index column, and we're going to bulk write the rows using kind of this multi-row writer. So 78 rows, 9 columns, and let's do the same for public schools, 566 rows, 78 columns. And then finally, the crime data, 533 rows, 21 columns. And again, I think this is from, I'm trying to see like what, I guess 2011, 2012, maybe. I think we're kind of a few years back. All right, so now what we're going to do is we're going to connect to the database. So any SQL commands we write will go against this server connection. This actually is how it's similar for like a Postgres connection string. I'll actually just pull that up real quick. So all the databases look pretty similar. Like they're all just going to have like connection strings that look like this, basically. This actually, I want the full one. Maybe the AI will give me the full one. Yeah, there you go. Postgres, SQL, and then your user password, all that good stuff. So it's basically just a copy paste to replace your database URL or URI with kind of the one here. So this is a SQLite connector. You would just swap that out for a Postgres connector. Question number one, find the total number of crimes recorded in the crime table. Two ways to do this. Select star, limit one. That'll give me kind of the show of what the table looks like so I can see all my columns and everything. And so now we can just use ID. I think that's my primary key is the unique value for each of my rows. Let's just count the number of IDs and we should get 533. And again, we can validate this number by looking at the 533 up here as part of our data frame shape for the crime data. All right, list the community area names with per capita income less than 11,000. Again, this first query just gets me the column names so I know what I'm looking for. In this case, we want community area number, that's the ID, the community area name, and we want per capita income, which is over here, and we want that to be less than 11,000. So select those three columns from census data where our income is less than 11,000, order by income ascending. And here we go. Riverdale has the lowest per capita income at $8,200. Step three, list all case numbers for crimes involving minors. So we're going to go back to the crime data. I went through all the columns up here and I chose description as the column that I wanted to query off of. Excuse me. So I'm bringing back the ID, the case number, the date, the type, the description, the location, and whether or not there was an arrest, where the description contained the word a minor. And I got two here. So we can see these are liquor law violations where illegal selling, giving, and consumption to minors in the back of an alley. And there was an arrest made in both of these. So similar problem, we want all kidnapping involving a child. So again, in this case, we're going to replace description with child, and then we're going to search for primary type being kidnap. Notice how I'm using like here, this keyword command plus these percent signs. This is essentially doing like a partial string match or a partial text match. I want to find all rows where the primary type contains these six letters anywhere inside of it, beginning, end, or middle. So we can see here that we identified kidnap right here. And this is case insensitive in SQLite. So primary type was kidnapping, and the description was a child abduction. So, uh-oh. And no arrest was made for this kidnapping in 2007, at least at the time that this data was pulled. List the kind of crimes that were recorded at schools. So this is the first one that I just put together. Select all of these rows from crime where location is like a school. But we want no repetitions in the type. So if I look at the primary type, we have a lot of battery here. So we just want to find one battery. So to do this, I'm using a select distinct, and we're going to be selecting distinct primary types and descriptions in schools. So whichever way you wanted to do this, notice they both answer kind of slightly different questions. This is getting the unique primary descriptions. This is getting all of the unique crimes that happened at a school. All right, list the type of schools with the average safety score. So average safety score. So same idea, pulling all the columns here, just so I know what I'm looking at. And this is where it gets kind of funky because there's some weird stuff going on with SQLite. So first we want to select where the column. This column, elementary, middle, or high school, it's a really wonky column. And so we have to, because it has like foreign characters inside of it, right? Notice how these other ones have like underscores and stuff. This one doesn't. It has commas and spaces. So because of the wonky column name, we have to put it in backticks. In other SQL flavors, sometimes double quotes will work as well. But for SQLite, I have to do it in this backtick format. So select this column and the average safety school from Chicago Public Schools, and we're going to group by that column as well. So if this all goes well, we see that the high schools have the highest average safety score, followed by elementary school, and lastly, middle school. But none of them are very good. This is out of 100, by the way. All right. List five community areas with the highest percent of households below the poverty line. This is going to be from census data, which we already kind of showed up here. So we can quickly run through it. We're going to be using the max here. Um, the max, even though this is going to be bringing back like one row, this will show us the highest percentage. Yeah. I don't even feel like we needed to do a group by here. I feel like we could have just sort of done it because I think this is unique, one row per community anyway. So no real need to do a group by, but whatever. I did one anyway. Yeah, I don't have enough time to like not do that. Or do I? How do I insert a new cell here? Uh, insert cell below. Yeah, so what I mean by this, if I just take this whole query again, I'm pretty sure that this is unique, so we don't even need to do a group by. So if I run this query, this should return the same results. Yeah, which it does. So yeah, no real need to do a group by here. So a couple different ways of writing the same query out. And then this example, I'm showing how we can read a SQL query using pandas and then read it into a data frame directly. So here we go. So now we've executed this query against the database and brought it automatically back into a pandas data frame, which is pretty neat. And then from there, you can do your own kind of downstream analytics, right? Almost done here. A couple more. Which community area is most prone to crime? This is where we got to do a join for the first time. Hooray. So we have our crime data. Usually I go biggest table on the left and then smaller table on the right. So our crime data is going to be the first one I'm going to pull from. That's my larger table. And then we're going to join the census data onto it. We can join to it via the community area number. That's going to be our ID for the location. So here we go. Take our crime data, join on the census data via the area number, and then we're going to group by the area name and number, and then count the number of crimes that was found for it. If all goes well here, Austin had 43 crimes, Humboldt Park had 22, etc., etc. And then this area number is just the ID for that area name. Next, use a subquery to find the name of the community area with the highest hardship index. So here we have a subquery that we've attached inside of the where clause. Select star from census data where hardship index equals, and then we open up our subquery. Select the max hardship index from census data. So the beauty of subqueries is that this allows us to be dynamic. If we got a new area with a new hardship index that's worse than Riverdale, then this query will automatically bring back that new community area. We're not hard coding in values that can lead to fragility and brittleness in our applications down the line. Last one here, use a subquery to determine the community area name with the most number of crimes. In this case, I didn't feel like a subquery was needed. I used a join. So I'll leave it as an exercise to the reader to refactor my join to use subqueries instead. But know that typically joins are more optimal in terms of kind of queries like this, both in engine performance as well as in readability. So in this case, we're joining our crime data to our census data again. We're grouping on the area, and then we're bringing back the number of crimes. So yeah, this is still going to bring back Austin. So this is wanted Austin to be brought back. So I guess if you wanted to refactor this as a subquery, maybe I will do it. Maybe not, because you'd have to have that group by and a whole one. So I'll leave that as an exercise for the reader. But the answer should be Austin. And there's nothing wrong with doing this and doing a limit one if you really wanted to. Austin. Boom. All right, so that is kind of your main idea of SQL. So again, in this little keynote project, a couple things you should understand is that first we did some read and writes, right? We created a database, we wrote data to it, and we also established relationships. For example, we established the relationship between census data and crime data via this community area number. So we have multiple related data sets or entities that we put into a database using pandas. So that's big idea number one. And then big idea number two were the different types of queries that we extracted from it. So, of course, we showed kind of the CRUD, create, read, update, delete, but we also showed some of the querying and analytical querying that we can do as well. Selecting columns, doing filtering, doing substring filtering, doing group bys, joining different tables together, and then even reading these queries back into Pandas data frames using the read SQL query function. So pretty good week, I think. Pretty good activity uh, to showcase things. What is this? Inbox. Gross. To showcase some of the big ideas of databases and SQL. So again, going into week five, we're going to be taking all this information and then we're going to be bringing it back into pandas and then doing EDA and building your first predictive model using linear regression. So I'll see you all in our next lecture on week five, which will be on Monday, and expect all those videos to be up at normal times. And I'll see you all next week. Thanks for watching. Take care. Have a good weekend and drop your comments into the forums. Oh yeah, last thing, week five also has some forums, so please try and participate as much as you can. I'll be getting to those tonight as well. All right, thanks everyone. Have a good one, and I will see you all soon. Enjoy the rest of your weekend. Bye.